second presentation I have. And this part is basically based on the Motorola GTR 8000 base station and the new Motorola method of doing simulcast. So our company, in previous I think 5 simulcast, large county simulcast installations we've done, had used the Harris Simulcast product, which is now Gates Air under their new name. And then we used like Motorola Quantar base stations. And then we used the Harris Simulcast for the timing. And then various products that keep improving over the years, especially the convex products for mixing your audio and those type of things, and they keep getting better and better. And these have been great products. I'd buy them again in a minute. Good companies, all working good, all reliable. But about 2 years ago, Motorola came out with a new simulcast product. And this new simulcast product is IP-based, it's analog, but it is at a price point that just can't be beat. It's amazingly reasonably priced. And as a result, it sort of just makes simulcast implementation, if you're able to sell a Motorola system with Motorola timing, a lot cheaper. I mean, it's just dramatically cheaper than the previous generation solution. So what I'd like to do is sort of go over and show you what that product is and how it works. So this entire product is based on this box called the MLC 8000. And the MLC 8000 is an IP solution. Inside the network, it uses UDP unicast, not multicast, and that's important because you can transport that over regular networks without having to have a dedicated multicast network like you do in some consoles between console elements. It works with the Motorola GTR 8000, which is the latest base station, which replaced the Quantar. It works with anything that has status tone receivers. As far as the voting goes, it still uses status tone voting. And it also has the, what it does for simulcast is it uses the baseband composite input. So on either the Quantar or the GTR 8000, you have a baseband input that starts at about 5 hertz and works its way up. So you inject into that, your PL or DPL if you want to try that, your PL and then your audio from 300 to 3000 as a composite input, which is how we've done it using the latest convex products in the 2 systems before the current 2 that we have now. So this box is the same. It's exactly the same box, but if you order it, it can be configured one of 4 ways. It can be converted as an analog voting gateway, which will take up to 4 analog receivers, or an analog voter. It's actually the same box. The analog voter part's at the other end. Analog simulcast control and gateway, that's all your simulcast timing. V.24 for digital operation, that's how Motorola talks to the Quantar, and it turns out they talk that same way to the GTR 8000. And then you can do mixed mode. Not simulcast mixed mode. It's part of a simulcast mixed mode. If you do Motorola simulcast P25 analog, it'll be the analog part of the mixed mode. But if you just have a voting system or a single site, P25, they had that with the Quantar product, you can do it still with this product. Pretty much anything that the Quantar did, the ML8C or the GTR 8000 will do, and this box will control either one. So it's completely backward compatible. So this is what it looks like. These are the various ports it has and what it looks like inside of a simple rack shelf. And what you really have here is, really what you use is you use these 4 ports on the top and these 4 on the bottom. These 4 on the top are the V.24 type inputs to Motorola P29 by digital type equipment. So we're not really using that in analog simulcast. These ports at the bottom, there's basically 4 wire ports that can be assigned and used in different ways. In a simulcast network, there's 1 of these boxes for every transmitter. It also has the input, you have references coming in. I'll talk a little bit later about how the reference works on it. This internal LAN, that's a goofy name, that's sort of part of a Motorola SCADA system. And then some various control things. But that's pretty much it. This is a GTR 8000. This is a replacement for the Quantar. It can be analog FM, P25 phase 1 or phase 2 TDMA. They're all software firmware type upgrades to go to each one. You can buy it just analog and upgrade it in firmware. and it's completely backward compatible with Quantar. I mean, I've worked with Motorola my entire career, and this is one thing that they really did right. You can basically take a Quantar, or the GTR 8000, put it anywhere a Quantar wasn't in virtually any application, and it'll still work, including all the old V.24 control systems and things like that. So they really thought this one out well. So in the 4 different configurations for the MLC 8000, the ones we're looking at for using it for is the ones I haven't read here. Configuration 1, which is the analog motor, and configuration 2 is the analog simulcast control and gateway. So in configuration 1, basically, it can act as a gateway to forward status tone receivers. Actually, if you have simulcast, your individual one attached to each transmitter also acts as that gateway, so you don't need a separate gateway. When it's used as a motor, it'll take a 4-wire console input on one of its 4-wire inputs. It has console priority and everything else. And then all the other receivers come in via IP to the motor, and then it makes the decisions and then does that type of thing. One thing to understand about this box is not a multiplexer. In other words, we can't put one at this end and say, here's 4-wire connection, and put another one at the end and say, audio comes out. The way it works is, at the far end, it takes in a status tone receiver. It processes it right there, and then it sends that process stuff back to the motor itself. It's not sending the audio back to the motor, and then the motor's doing all the processing in the motor itself like a traditional comparator. So it's not a multiplexer, but in reality it acts as a multiplexer. You don't need a separate multiplexer anymore because you just took this box at one end to your base station and at the other end you took it to your comparator. And that's it. When it's used for simulcast, there's one on each attached to each base station. And then one of them within the network also will then act as your control. You can assign one anywhere to be that. You can adjust all the basic simulcast parameters in it inside the box. It has parameters for adjusting, making sure the GTRs match each other in case there's manufacturing differences in the future and that kind of thing. So finally, there's a couple other ways you can use it as was describing in the V.24, which is all part of using it as part of a legacy P25 system. The documentation is outstanding. And the reason I added this slide is a lot of us have been around this industry for a long time and can remember when Motorola had great manuals. And then they had a little period where it wasn't so great. And it was a little hard to find out anything that was going on inside. You know what? They've sort of went back. And I mean, I can't quite figure out why the regular manual is 102 pages and the quick guide is 230 pages. All I can say is it's very Motorola. But everything you want to know is in there, all the configuration, everything you can imagine. There are schematics, you know, down to the component level for all of the ports. So you know if you're connecting to a port, you're having some kind of an issue, you can look at the schematic, it's outstanding. So it's sort of gone back, this is true of all their products recently, just really gone back to really excellent manuals. So here's a block diagram of how this would work in a system. And this particular block diagram is, say, a 5-site system with a main site and then 4 satellite sites. And this just shows an example, sort of one transmitter to each site. So you basically have your voting comparator. Everything in red is your IP network. You come down through some kind of IP backhaul. Here I use IP microwave. Right into the MLC 8000 has a Spectracom DPS or master oscillator attached to it, which can be Spectracom or low one cell zone also. You have your GTR 8000 and then any filtering you have and that type of thing. So actually at the master site it's exactly the same. And the only thing different is you'll have one extra MLC 8000 which acts as a comparator and then the interface back to dispatch. But it's the same box everywhere. This next diagram shows if you're at a single site that we take, just look at a single site, how do the 3 channels look at this site? So you're coming in off your microwave. These 2 boxes are Motorola boxes. They have a specific router called the GTM 8000, and then they have a specific managed switch called the 2610-24. It's made by HP. We always buy these. I guess you could do that without this, but this product is not, available to regular dealers through the price book. This is what, in Motorola, this is a sort of a manufacturer's representative kind of product. So you have to go to Motorola and say, hey, we'd like to buy this separate, will you give us permission? We get that for our company because we basically done simulcast for so long. If you're a regular Motorola dealer, you sort of have to talk to them. Well, that may be implementing this solution. If you're not Motorola, they're not going to sell you these boxes, so you can attach them to some other kind of unit. But they have their own router, and they have their own managed switch. And those are IP products, we always buy them. And the reason we always buy them is, in the year's future, you just don't want to be calling up Motorola on your phone and they say, oh, you're using your own IP routers and that kind of thing. See you later, you're on your own. And that's not a good thing. So we always buy the Motorola routers. So Motorola router, Motorola switch at each site. And the other end, there's also a Motorola router, that type of thing. This is a script-based router. Script-based routers mean you enter scripts. You're not opening up a page and then, selecting things. And, this is true of most advanced routers, because with script-based routers, they tend to be backwards compatible in the future. In other words, if you put a script from one 5 years ago into a new one, it'll still run it the same. And so you have to know how to do script-based routing. That manual's about 1,500 pages for that router. And all the various, it's very powerful, you can do almost anything with it. So from that, and come down here, and you're going from your switch, you're going IP, and into the various units. You have one master oscillator connected to each one. You have a set of filtering, and you have 3 transceivers. Now what I show down here is you can have a site. The way it works is so long as any individual channel is all the same transceiver, you can do it. So on an individual channel, it has to be either all GQR 8000 or it has to be on Quantar. You can't mix and match on the same frequency, same channel. The timing and the frequency response of them is different. So you have to go one. But if you have legacy Quantars, you can actually migrate them in to a simulcast system. In the way we communication service implement this, we buy the SpectraCom Secure Sync timing for all the GPS timing. Motorola sells a unit made by Track. We just like the SpectraCom better, so we buy it separate. If you do buy the unit, you have to buy this particular, what's called TTL output card, because the input into the Motorola system is a 5 megahertz composite input. So in other words, you got your 5 megahertz reference for your, basically being on frequency, and then your 1 PPS pulse every 1 second is basically a change in that waveform. And to get the SpectraCom Secure Sync to do that, you have to buy this particular card, and this particular card will drive up to, say, 4 Quantars or 4 GTRs, whatever you want to use. And there's a specific program you have to enter into that. So if you do that, you contact Ed O'Connor. He has the program, and he'll send that to you, that you enter into this card, and then it'll operate as the timing source. We like the product a lot because it has, you have a lot of alarming and other things that come with the SpectraCom product. For our microwave, one of the keys we try to do in the microwave is either use a separate LAN or a separate VLAN for radio-only traffic. That sort of depends on your microwave, for example. If you can configure the microwave for there's completely separate LANs, we like to take one LAN, put just the radio traffic on that, and that's it. Make sure that that capacity is so big, nothing can ever go wrong. That's sort of our solution in IP to try to be as reliable as, say, a T1 network. Just give it its own bandwidth, don't let anything. So don't be at, if you promise you go to the site, you have a management, you come out there with your thing, and you start downloading things or something, you can sort of mess up the network. You can do that also with VLANs, virtual LANs. Depending on how your routers work, or depending on the microwave you use, you can control that with VLANs also. So let's say you have 10 megabits per second of bandwidth, you could allocate 5 or 6 megabits to the radio traffic, even though you can never use more than 2, and then the rest for alarms and any kind of management traffic that you don't have. That's sort of our solution to that problem. 2 products we like is the XVIII 4.9 megahertz microwave. It's an all-indoor unit. Doesn't have hot standby, but it's a very good replacement for the MBSGU leader product. You can actually use the same feed line, just replace the antennas. And for the most part, the link budget is just about as good. 4.9 gigahertz, you can use 2-foot, 3-foot, 4-foot dishes, that kind of thing. We like indoor product, and that's turned out to be a pretty good one for us. If we go to 6 or 10, 11 gigahertz, we use the Aviat product, X Harris product for microwave. So in summary, every time I've come up here and done a presentation, I always have a little bit of a philosophy around Simulcast, and the philosophy is you got to minimize the variables. You just don't want to have extra things you're dealing with. And the first one is try to have some kind of reliable backhaul, not a backhaul that's changing on you. In the IP world, unless you want sites going out, don't be trying to run this backhaul through DSL modems and that kind of thing. I mean, stay away from any kind of a public network that you don't have control of. Have complete control of your network. Well, if you have dedicated microwave with IP, use VLANs and VLANs, then you can do that. Keep your identical audio response over time, and this sort of comes to the Motorola product. Once you put a GTR 8000 or a Quantar in, it doesn't change over time. I've come back to systems after 5 years to re-optimize them, nothing has changed. So what Motorola does, and I think there's at least one other manufacturer does, is when they start making a base station, and you start making a simulcast base station, that audio response stays the same over time. There's some other manufacturers where they aren't just quite as tolerant of that, and then they basically put in kind of an audio equalization system. You press a button and it sends all kinds of tones, and that's how it optimizes the equipment. I'm not a fan of that. I mean, I don't want to have to go press magic buttons or once a week have to go through some kind of routine because the equipment is changing over temperature or something like that. Just everything stays the same over time. Eliminate your time delay changes. That's pretty standard these days with the IP type simulcast system. You're not dealing with fixed delays anymore. Everything is any changes that come accounted for. Simplify design. We use the Motorola Quantar and the GTR 8000. And finally, I'd say, our experience has been good with simulcast. We just got 2 more contracts. Both of those contracts came about essentially because the customer went to narrowband and didn't have enough sites. So one customer is a new customer. They only had maybe 1 or 2 sites for a huge county. So when they went to narrowband, it went from bad to really bad. And another customer of ours had a 4-site simulcast system, but really they actually went to a 9-site system because of this difference in narrowband coverage. We have a bunch of other customers that had 7, 8 site type systems and went to simulcast, and basically the coverage was ubiquitous enough that there was no issue. You didn't really have an issue with them. Yes, there's a tiny loss in coverage, but the coverage was good enough that they didn't really notice that. In other words, you're sort of saturated. So that's been our experience. So with that, I think, Ed, I'll yield it over if that works to you.
It does. Let's take a couple of questions now, and we can take more at the Q&A session later on. So a couple of questions for
Sure.
Andy?
Hi, Andrew Rushat. Going back to your comments about P25, and I think you're right on with everything. And I just wanted to add this. I think that P25 and simulcast, or P25 in general, sometimes makes it more difficult to troubleshoot problems. And the reason I say this is, in the analog world, if you got an uplink limited signal, you can hear it.
Right.
They dekey, and then the repeater hang time, everything clears up.
Yeah.
That's on the uplink. And then if it's always bad, it's on the downlink. And then if it's multi-path, you hear that raspy audio.
Yep.
With P25, a bit error rate is a bit error rate. And as a user, you don't know if that's uplink limited, downlink limited, or if you're there's not 3 LEDs on your radio. One says your input's bad, or your output's bad, or you're in a simulcast zone. And then ultimately, if you got IP link sites, if your links are taking a hit, that still translates to a bit error rate, a bit error,
right?
And that comes out the other end. So you're like perplexed as far as troubleshooting. And then one last thing, and I'll shut up. And then on the P25 side, the radios, they really have to be herded in a whole lot more accurately as far as their frequency error. And if you've got radios with bad frequency error and bad mod fidelity, it can actually send you down the road thinking that the problem is on your infrastructure side when you got a a couple bad radios out there that are out of alignment. My only comment is I think managing all that, it gets a lot more complicated with P25.
Yeah. I think what's happened in the industry in the last few years too is in the consulting world, consultants have put in P25 systems and sort of ran into some of the things you're talking about, and that's created more of a tolerance, I think, for continuing on with analog systems, just because people have experience. In other words, they've gone through trying to do it in a remote county, and then gone through some of the subscriber issues, and then gone through some of the, sort of like blackout. You're between two sites and the signal's good, and all of a sudden, you can't talk and that type of thing. And I think that's what's happening, and that's another reason I think analog simulcast, it definitely has a few years left. Just some of the implementation things. Yeah, Tom.
Do you see any issues with manufacturers end of lifing the analog? You got like a 10-year.
This equipment,
Yeah.
I don't see that. Partially because, like, at least with this box, it's used for P25 systems too. It's got all the P25 software in it. If you're doing P25 voting, that kind of thing, with the VDAT 24 links. So I don't see, they just came out with this product. I don't think that's going to go away anytime soon. So, but I've seen it also in some more things in specifications that come out from consultants where if you want to put in a P25 system, then I'll have you test all the radios and all these kind of things, and you sort of start to see that show up in the specifications if you want to do a P25 system. So, which I think is a good thing.
Yeah, I recently had an opportunity to listen to one of these systems. However, they implemented it using the T1 links. It's IP based over T1. And I noticed that the audio sounded like they had more aggressive roll-off on the lines. Is that an effect of being over T1, or are they doing that just to reduce the simulcast?
I don't think that's like a backhaul issue. That could be some other kind of issue. But anytime you have simulcast, whenever you start to have timing difference, you always hear it on the highs first.
Yeah,
You start to get the distortion on the highs
local
first.
to the site. I mean,
Yeah.
it just sounds like they have more aggressive roll-off.
I think that's sort of could be something in how they transport the audio or how the multiplexer works or something like that, something related to that. Mind you, if it's the same everywhere, it's okay, but
You are digitizing the audio.
yeah.
That's coming back. So
Yes.
you are going through it. But it's actually voice over IP and not vocoder.
Yeah, and at least in this system, they're not vocoding it. So I mean, I think the transport rate is over 90 kilobit per second or something like that. So they're sending the whole stream back.
Can you choose, Steve, can you choose on there between G711 and other protocols as far as the actual coding?
I think so. I don't know that level of detail though. I don't know that level of detail. So I guess sometimes when you have some of the, some of the protocols, depending on how you're transporting it, I mean, at least the way we do it, the transport is all private anyway. So, and it's all isolated.
I've done one system with a P25 capability of this,
Yeah.
and it carries the P25 envelope data all the way from end to end.
Oh, okay.
So it just knows, you set it up that way to transport.
Right.